Okay, let's dive right in. We see graphs and charts literally everywhere, on the news, in our work, all over social media. And they're supposed to make things clearer, right? But what happens when they're actually designed to trick you? Well, don't worry, because in just the next few minutes, you're going to know exactly how to spot the lie.
And that's a real question. A cleverly designed graph can make a tiny, insignificant change look like a world-ending crisis. Or it can make a really dangerous trend look totally fine, nothing to worry about. It basically plays on our instinct to just trust what we see.
That's right. Think of this as your official detective training. We're going to open up the case files on the most common visual tricks out there, and I'm going to give you the tools you need to see past the deception and find the real story the data is trying to tell you. So this is what we're up against. It's called the visual lie. And here's the sneaky part. It uses technically correct numbers, but it manipulates the design, the visual part, to tell a completely different and, often really misleading story. Let's get into our first case. Okay, our first case file is an absolute classic. The official name is the truncated axis, but I just call it the case of the missing zero. And believe me, this is one of the most common and powerful ways to bend the truth. So, what is it exactly? It's actually super simple. Instead of starting that vertical line, the y-axis, at 0 where it should be, the person making the graph just chops it off and starts it at a higher number. This one little edit has a huge effect. It takes tiny, meaningless little changes and blows them up to look like these massive, dramatic shifts.
And here it is in the wild. Check out the graph on the left. By starting the axis at 3%, that tiny little hop from 3.1% to 3.2% suddenly looks like a terrifyingly steep climb. It's built to make you panic. Now, look at the right. That's the honest graph. When the axis starts at 0, where it belongs, you see the truth. That skyrocketing rate was, it was just a tiny little bump. It's the exact same data, just telling two completely different stories.
All right, let's move on to our next case. This one is a little more subtle, a little sneakier, but it's just as misleading. We're going to look at how the actual shape of a graph can be manipulated to fool you. This trick is called axis scaling, and all it is stretching or squishing the axes of a graph. By doing that, you can completely change the emotional reaction someone has to the data. You can make a totally stable trend look like it's exploding, or you can make a really volatile trend look calm and safe. Just think about a company's sales numbers. If you want to create a panic, make it look like things are out of control, you just stretch that vertical axis way, way out. All of a sudden, normal, steady growth looks like a crazy, unsustainable rocket launch. But what if you want to reassure people? You just squish that same axis way down. Now a stock with wild up and down swings looks like a totally stable, safe bet. You're controlling the whole story without changing a single number. Okay, for our final case file, we're going to look at something that seems pretty innocent, almost kind of fun, using pictures instead of plain old bars. But don't be fooled. This pictograph trap is probably the most mathematically deceptive trick in the whole book.
So the problem kicks in when you use 3D objects, like little illustrations of oil barrels or bags of money, to show your data. Our brains just are not wired to interpret this correctly. It's all because of a math principle called the square-cube law.
Now here's the wild part. Let's say you want to show that profits have doubled. So you take a 3D picture of a money bag and you make it twice as tall. Seems logical, right? Wrong. See, when you make it twice as tall, your brain instinctively sees it as twice as wide and twice as deep too, to keep the proportions right. And the result? We don't see it as double. We perceive it as an 8 times increase. 8!
And that is the trap. Your eye literally registers 8 times more volume, 8 times more stuff. So it tricks your brain into thinking that a simple doubling is actually this massive world-changing event. It looks cool, for sure, but it's a total mathematical lie.
Okay, so we've seen the crimes. We've investigated the usual suspects. Now it's time to give you the tools to protect yourself. This is your personal toolkit for interrogating any graph that crosses your path. It's just a simple 4-point check. First up, the title. Does it actually tell you what you're looking at? Second, the labels. Are both of the axes clearly marked? Do they have units? Third, and this is the big one, interrogate the scale. Does that vertical axis start at 0? Are the numbers going up in a steady, even way? And finally, number 4, check the source. Where did this data even come from? Is it a source you can trust, or did it just appear out of nowhere?
So here's the most important takeaway from all this. You don't have to be a math genius to avoid getting fooled. With this simple checklist, and now that you know about these common traps, you are officially equipped to be a data detective.
You can look at any graph with confidence and figure out if it's telling you the truth.
And this is where it gets really fun, because now that you can see behind the curtain, you're gonna start noticing these things everywhere. So the real question isn't if you'll find a misleading graph, it's which one you're gonna call out first. Happy hunting!